Hi guys, earlier we have discussed the electrocyclic reactions and how the selection rules gives the stereochemistry. When we have applied the thermal condition, it's undergo conrotation for 4 pi electron system, and for photochemical condition this 4n pi electron system undergo disrotation. Now we will see how the stereochemistry looks like when there is a substitution. Let's one example of cyclobutene disubstituted cyclobutene system is undergo ring opening electrocyclic reactions. We can easily understand this by one model representation. So this is looks like the cis cyclobutene system. When it gives the thermal condition, it's undergo ring opening via cone rotation process. Either the orbital rotation will be the clockwise motion or it will be the counterclockwise motion. Let's see, all will be the clockwise motion orbital. It looks like that. Then that means it gives that this is trans cis product. Either if we will go counterclockwise motion, it will give the cis trans product. This is here it looks like. When it's this ring opens via photochemical condition, so this then it follow the disrotation motion. Either one opens through clockwise, another is anti-clockwise, gives the trans conjugated diene system, or if one which follow the clockwise, if it's follow the counterclockwise motion, other follow the clockwise motion, it gives the cis product of the 1,3-butadiene system. But the product formation all depends on the stability of the product, and then it's follow the geometry. Now we will see for 4n plus 2 electron system one example of this disubstituted 135 cyclohexatriene. When it's undergo ring closing, how the stereochemistry looks like we will see. If we put here thermal condition, this rotation will happen, and if we give the photochemical condition, cone rotation will happen, and we will see the different stereochemistry of the product. In thermal condition, this rotation happen, so here homo Psi3 will be undergoing the reaction. So let's see, this is the Psi3 homo. So it will follow the disrotation under thermal reaction condition. So the one will be the counterclockwise, other will be the clockwise, give the effective orbital interaction, give the cis product. So the same way that outer word means the below lobes also can undergo disrotation this way. So now this is also other way the cis bond is formed. Two are all substitution at the below position. Now if we will give that photochemical condition to the system, so Psi4 will undergo reaction for this. So now it will be like this, system will looks like this, and if Psi4 undergo orbital interaction for photochemical condition, now it will follow the cone rotation. Now see how it looks like cone rotation. Now all will go either clockwise orientation or all will go to the counterclockwise orientation. So that means if it will go this trans system follow the cone rotation, gives the trans product. Either this way cone rotation also gives the trans product. So always E system of this hexatriene system disubstituted product, cone rotation give the trans product, and this rotation give the cis product. Now we will discuss another we will discuss some different types of selectivity in pericyclic reaction. One is the torco-selectivity. What is that? If this cyclohexatriene system have the defined substitution in the terminal single bond, then terminal alkene system, then under thermal condition we can see that this rotation happen. This rotation either follow the inward motion or either follow the outward motion. Already we have shown that if this happen through inward motion of the orbital, then it will give that cis product. If it follow the outward motion, it also give the cis product, but as we have the different substitution, so we finally for two different types of rotation gives the enantiomer. In case of the photochemical condition, also either follow both the orbitals follow the clockwise or both follow the counterclockwise, also gives the one setup which clockwise orientation of orbital gives the which enantiomer of the product, counterclockwise gives the other enantiomer of the product. So that means only by orbital rotation of different types gives the different enantiomer of the product. This type of selectivity called torco-selectivity. Let's see one example. Like this cyclobutene system have contains one methyl ethyl substitution. Methyl is the above this ring and ethyl is the below of this ring. Stereochemistry, where giving the thermal condition we find the product, this trans product is formed, whereas that is happens when this undergo the when this above the bond go outward and that below ethyl go this will go the conrotation motion, so this will come to the plane and this will also come to the plane. That means both are counterclockwise orientation this trans product form. If this follow that clockwise motion, this up bond will come inward of this ring and ethyl also from below the face it will come the inward. So that means this cis product this butadiene system can form, but this was not the right observed product because of steric strain. Now another type of selectivity is the site selectivity. So site selectivity is a general concept for this pericyclic reaction. When there are two or more possible sites for reaction, one its predominance over the other and the product formation depends on the steric factor. Now we will come to the regioselectivity. What is that? It is a special type of site selectivity. Let's explain this site selectivity for sigmatropic cases. This is the 1,5 system where this 5 position hydrogen can shift to the 3 position or 5 position. So that depends on the reaction condition and feasibility. So this is the case we can see having the other possibility, one is getting predominance. That's why here site selectivity come. Now we will explain the regioselectivity. So that formation of a new bond, especially this observed in the cycloaddition reactions. Formation of a new bond in different orientation. Looks this is the 1,3-butadiene system here, and another is the dienophile system, dienophile, homo and lumo. So if this orientation is undergo reaction, this 1,2 bond form here, two substitution are the 1,2 position. This is the major product. If this switches shifted this double bond in other orientation, then we can see the homo-lumo interaction gives the 1,3 substituted product, that is we observed as a minor product. Why this happened? This can be explained by Huckel-Emo theory, where we consider the orbital coefficient term. Here this is the orbital coefficient value we have put it here. Here it is plus 0.3, here it is minus 0.58. In this case dienophile, this position also have minus 0.66, and other near to Cn, that orbital coefficient is plus 0.2. So that means the bigger orbital coefficient always interacts with the bigger orbital of the other diene system, gives the efficient orbital interaction and leading to the formation of major product. Whereas if we reverse it, then orbital coefficient also changes its value only by negative sign. So this plus 0.2 becomes now minus 0.2, and other we have minus 0.58. So that difference is much more. So but this orbital interaction happen very minor way, gives the minor product. Now we will see the Diels-Alder reaction, how normal or inverse electron demand can be happen. So generally we see that Diels-Alder reaction are the cycloaddition reactions, where HOMO of a diene system and LUMO of a dienophile system undergo reaction, give the efficient orbital interaction and generates product. But if a dienophile HOMO undergo reactions with the diene system of the LUMO, then we can see that can be called a inverse electron demand of Diels-Alder reaction. So this is the just general concept I have given here. We have more example we will see later. Another term of selectivity is the periselectivity. What is that? If there is a preferential formation over multiple possible in a pericyclic reaction, like this is the system, two system undergo 2 plus 4 cycloaddition reaction, 1,3-butadiene type of system plus arine, or we can say benzene, 2 plus 4. Again this 1,3-butadiene system, one in system undergo interact with this benzene, gives 2 plus 2 addition product can generate. Also this 1,3-butadiene system have some hydride of the other end that undergo also through cyclic transition state, hydride can shift or in type of reaction can happen. So having the possibility of different multiple pericyclic reaction, one predominates over the other, this type of selectivity is called periselectivity. So this depends on the which type of product will form. It depends on the activation energy of the reaction, also the stability of the product. So thank you guys, we will discuss the other topic on the next video.